This video is about basic integration. The process of finding y from dy by dx or f of x from f prime of x is the reverse process of differentiation. We call this anti-differentiation or integration. Look at this diagram. From y or f of x, get the dy by dx or f prime of x. The process is called the differentiation. Then we need to do the reverse process of this differentiation. From dy by dx or f prime of x, figure out the y and f of x. This process is called the anti-differentiation or integration. Let's think the following statement. If f of x equals x squared, we know the derivative of f of x is 2x. But if derivative equals 2x, then f of x equals x squared. Is it true? Definitely not. Think about if you have x squared plus 1, when you do the derivative, you still get 2x. In other words, for this f of x, it could be x squared, it could be x squared plus 1, it could be x squared plus square root 2. And so on. There will be infinite solutions to this f of x. But the pattern of the solution to f of x, it will be f of x equals x squared plus c. C is all real numbers. Now let's go to second one. If f of x equals x to the nth power, then f prime of x equals n times x to the n minus 1th power. So if dy by dx equals x to the nth power, what's the f of x will be? Since this process is a reverse of differentiation, therefore it will be the reverse operation of this differentiation. The first step is times the exponent. Second step, the exponent minus 1. Now we will do the backwards. You have to make sure the order is backwards and also the operation is backwards. Therefore, this f of x will be exponent plus 1. So you get the x is n plus 1. This is the exponent. Then times the exponent. The reverse will be divided by the exponent. Now the exponent here is n plus 1. So divided by n plus 1. Don't forget plus c. And c is all real numbers. Now let's look at the 3. F of x equals ax plus b to the nth power and f prime equals. We got to use the chain rule to figure out the derivative. So we get the drop down this n, then it's ax plus b to the n minus 1th power times. The derivative of ax plus b will be a. Now write down the order. First of all, it's you times exponent. Second step, exponent minus 1. Third step, you times the coefficient, that's a. Therefore, for dy by dx equals ax plus b to the nth power, then we will do the backwards here. Times a, you have to divide it by a. Exponent minus 1, you have to make sure your exponent, you plus 1. Then times exponent, you have to divide it by exponent. Let's rewrite this. You will get 1 over a times ax plus b to the n plus 1th power over n plus 1. Then remember you have to plus c. And c is all real numbers. So far, and we already got this. But we want to check this n. Is it n will be all real numbers? Let's go to number 4. We have dy by dx equals 1 over x. If we want to use this rule, we got to do is 1 over x equals x to the negative 1st power. If we want to apply this rule to figure out this f of x, you will get f of x equals x negative 1 plus 1 over negative 1 plus 1. So you will get the x to the 0 power over 0. That is 1 over 0. We know the 0 cannot be denominator. This is undefined. In other words, when n equals negative 1, this rule won't be applied. In other words, for this rule, the n cannot be negative 1. Now let's talk about the notation of integration. If f prime of x equals f of x, for x is in an interval a and b, then we use this symbol called the integral of f of x dx equals f of x, use the capital letter F plus c. And this c is all real numbers. This anti-differentiation of f prime of x equals f of x, we can write down this way. Integral of f prime of x dx equals f of x plus c. This is very, very important for you to think how to figure out this f of x. For example, we know 1 over x. We cannot use this formula, integral of x to the nth power, x n plus 1th power over n plus 1. But we do know that it's the natural log of x. Derivative will be 1 over x. Therefore, we can do the backwards. You will get natural log of x plus c. Why we put the absolute value here? Because the domain of log argument must be greater than 0. Using the same method, we can figure out the following integral of a function, like integral of cosine x dx. You will get sine x plus c, because derivative of sine x equals cosine x. Second, what about integral of sine x dx? We do know that cosine x derivative equals negative sine x. Therefore, we can make here is negative cosine x equals positive sine x. Therefore, you will get the negative cosine x plus c. Integral of ex power dx equals, we do know the e to the x power derivative equals itself. Therefore, you will get the e to the x power plus c. Let's go to fourth one. Integral of secant square x dx. We know tangent x, we do derivative, you will get secant square x. Therefore, the integral of secant square x will be tangent x plus c. Number 5 will be this. For number 6, we discussed just now. Remember the natural log of x, the derivative will be 1 over x. Therefore, the integral of 1 over x dx will be natural log of x plus c. As long as you are familiar with these 6 integral rules, that's enough for IB, AI, HL.